Given the function f of x is equal to 5 minus 2 times the absolute value of x plus 1, sketch a graph of the function, state the range of the function, and then solve the equation f of x is equal to 5 over 3 minus 2 over 3x. Okay, notice the critical value of this will be minus 1, so it's whatever this makes this equal to 0. So, if we draw a set of axes, okay, I'm going to mark on minus 1 with a dotted line, and I'm going to remove the dotted line. When x is less than minus 1, y will be 5 minus, and then this bit here is negative, so we'll put a minus sign in front. So we get 5 plus 2x plus 2, and it gives you 2x plus 7. Okay, then for y is less than minus 1, we draw the line y is equal to 2x plus 7. So there's 7, and then with a gradient of 2 going downwards that way. So it's a positive gradient, but it keeps going, so that'll be 7 up to there, but we don't draw that bit in. Okay, and then we do the same for when x is greater than 1, and that is when y is positive, so it just behaves like it's written really. So 5 minus 2 times x plus 1, which is 5 minus 2x minus 2. 5 minus 2 is 3, so we're going to have minus 2x plus 3. So mark on 3, and then for every one along, we're going to go 2 down. We get the gradient here, and we get sort of a V-shaped graph. Okay, so labeling the graph, it should look like that. Now, the range of the graph, well, the highest point here is 5. Okay, so it's not valid for values of values of y greater than 5. So the range is y is less than or equal to 5. To solve 5 minus 2x plus 1, the absolute value of x plus 1 is equal to 5 over 3 minus 2 over 3x. Same again, when x is less than minus 1, this bit behaves like this. Okay, so that becomes plus, so we get 5 plus 2x plus 7 is equal to 5 over 3 minus 2 over 3, which gives me 2x plus 7. So I could have not done that, but and just said for this, it's 2x plus 7 from my previous part of the question. Now, the 3 divided by 3 will be easy if I bring it up here and multiply by 3. So I just have to put this equal to 5 minus 2x. So it gives me 6x plus 2 is equal to 5 minus 2x, which gives me 8x is equal to minus 16. X is minus 2. And then when x is greater than minus 1, similar sort of idea. There's no minus sign this time, it just behaves as it is. So we get 5 minus 2x minus 2 is equal to 5 over 3 minus 2/3 x. So that gives me minus 2x plus 3. And again, we could have just taken from part A, this part, to solve it for when x is greater than minus 1. And multiply by 3, we get 5 minus 2x. So we get minus 6x plus 9 is equal to 5 minus 2x, which gives me 4x is 4, and that gives me x is equal to 1. So I get solutions x is minus 2 and x is equal to 1. Just a note, if you try to solve it for greater than this and get a value less than minus 1, then you know that's not a solution. That possibly could happen in a different problem. And then finally, there's a graph of the whole situation. That's the original absolute value function graph. Here is the graph 5 over 3 minus 2/3. And you can see very clearly it cuts up the intercept at minus 2 and 1. Okay, this has been a video to show you how to draw an absolute value function and how to solve an equation and the geometrical meaning of it. I hope you've understood, and I thank you very much for watching.